Okay, paper 2 physics, nuclear reactors. So knowledge check. Hopefully you can just go bam, 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 and you can recall this knowledge straight off. If you can't remember, you go to my resources, and we have a whole page in this content. You can revise it quickly. Hopefully this video, though, will be enough that you need. You're thinking, what happens to a neutron that hits the moderator? We know that a neutron hits the moderator. It's going to collide with the moderator, and it's going to do an elastic collision. So remember, elastic means that kinetic energy is conserved. So it's going to lose kinetic energy, right? So that's going to happen to the neutron. So again, the neutron is coming along. We're going to get it collide with a moderator. Our moderator is sometimes made or often made of water or hard water or something like something made of carbon, right? Because what we want to do is the neutron is going to hit the water and then it's going to move off. It's going to move off with less speed than before, right? Because every time it collides, it's going to lose some of that kinetic energy. And you want the moderator to be a really small molecule, right? You want it to be quite similar in size to the neutron so we can lose as much kinetic energy as possible in that one collision. And remember, the reason we need these neutrons to be slowed down is so they become thermal neutrons. So they can get absorbed by the uranium-235. So what is fission is when a neutron is absorbed by uranium-235, and it's going to temporarily become uranium-236. And you need to know that uranium-235 is your fissionable isotope. Because remember, you've got another isotope of it, uranium-238, and when it absorbs a neutron, nothing happens, right? But it's uranium-235, when it absorbs a neutron, becoming uranium-236, that one is going to split into two smaller nuclei and releases energy and more neutrons, and say like 2 to 3 or 3 more neutrons. Okay? However, sometimes this can get out of control. It goes out of control, that's when we get a nuclear bomb. So we need to control this, right? We can't have too many neutrons, because we only want one to get absorbed to cause that fission, but we're getting 2 to 3 more produced. So we're getting too many produced. So we need something to take away some of those neutrons. And that's why we have these control rods. The control rods, the purpose is to absorb the neutrons so we can control the rate of reaction. Okay? And we know then this whole thing is going to be really hot. We don't want the nuclear reactor to overheat, so that's why we have a coolant. And we also have a coolant to take away that thermal energy and then transfer it to the boiler, right? So we want properly the coolant. The coolant wants to absorb as much heat as possible. So you want to say that it's going to have a high specific heat capacity. It's actually a similar question that comes up in GCSEs.